we want to plot the deformations. Let's do auto compute. We want to see how does this node here, how does it move when we apply the force. Right, so we want to have a plot of one node in the y direction, the displacements in the y direction, compared to the amount of force we apply. So we can go to create XY data, and we can go to ODB field output, continue, and select, let's see here, U, and then U2. Then we go to element nodes, and we go to pick from viewport. We select this node and edit selection, and now it says one node selected, and then we can go plot, and this is what we get. Remove this. So we have displacement here, we have time here, but the time is actually it's a virtual time. It's a time from your initial step to your step one. So initial step, we didn't have any load. In step one, at the virtual time of 1, we have our full load, which is 1000 newtons. So this is like, you can replace this with newtons from 0 to 1000 if you would. So what we have here is then that at 0 newtons or 0 load, we have, well, 0 displacements, and then they increase linearly as we load this thing. Right, this is linear elasticity. And let's compare this really quickly now to something else. If you go to ODB2 here, we can see a different kind of problem here, where we have the same thing, but it's loaded until it crashes with this box here. So this is some weak material, and we can check out how it looks like. This is where the load is applied. If we change this to CF, we can see here that the load is actually 10,000 newtons applied to this point here, which is really bad, but you know. Oh, and the scaling factor has to be changed because right now it's crashing into the box. So uniform 1, okay, this is how it looks like. And let's go to the stress here and see. This is a contact problem, and it's a, well, nonlinear, and let's see why it's nonlinear. If you go to plot the XY data again, ODB field output, continue, select the position is unique nodal, go to, and you know, if you have integration point, you will not even get the displacements, but because the displacements are only computed at the unique nodal. And the difference between unique nodal and element nodal is, well, the element nodal are not unique, they're unique to each and all of the elements. But so you have, well, one node here, which is, you get all of these 4 elements, you get the values of, you get 4 values, right, because there are 4 elements sharing this. And the displacements doesn't exist in those kind of nodes. They are unique, so you have to select unique nodal. That's where you get this option. All right, so U2 in the y direction, right, and go to element nodes, select one of them, for instance this one here, and edit selection. Come on, update. Select nodes in viewport. That's what I've done. Do it again. Edit selection. What now? No? Yeah, no. Press done, and then you have it here. And then plot. Close this down. And this is what we get. Again, our time, this is a so-called linear study. I mean, we have only one step. We have the initial step, and then we have step 1. So we have placed our load at step 1, like we did in the previous study, without the object colliding with it, without the contact problem. But now we see that this is not linear. It goes down, and then it sort of goes up again, right? So this is a proof that this study is not linear.